So many of the common visualization formats that we use in practice are designed to give us a sense of the shape and spread of a distribution of observations. And histograms are no different. So this is really kind of a bread and butter technique. The problem with histograms is that there are a couple design features that we can choose one way or the other way, which can really change at least how the thing looks, if not how we interpret the conclusion. So let's talk about not just histograms, but some of the details in Tableau. So to do that, let's start a new sheet. And here we're going to be thinking about the distribution of book prices. So price lives within the edition data sheet, and we're going to drag this up to rows so that this is going to be on our vertical axis. So right now we're showing the sum of the price, which means the sum over all the editions of all the books is around $1,600, but that is a kind of a meaningless number. And so what we want to do instead is go over to Show Me and go to Histogram. When we do that, notice we have a new variable in our workspace called price bin, like we've binned it. More on that later. For right now, what this is saying is that the bin here that I've highlighted goes from, let's say, $9 to $13, and this is saying that there are 37 editions that fall in this price range of $9 to $13. There are 8 books that lie within the range 13 to 17, and so on and so on and so on. So the bin markers, as we'll see, are up to you, but the basic idea is the higher the bar, the more observations we see within this bin. Not super surprising. The kind of crazy thing from a Tableau perspective is, as I mentioned, this new variable has been created for us. And if we click the little triangle next to it and say Edit, we can actually dive into its kind of inner workings here. So one thing, kind of the thing really, is the bin size. Like, how wide is this bin? And Tableau does its best to pick the appropriate value, but I have to tell you, like, that's never actually been the value that I wanted to use, because, like, who thinks in increments of $4.43? I would either think in increments of dollars or in increments of 250 or maybe 5. Let's just try increments of 1 and see what happens. So if we change the bin size here to 1, notice what we get. This histogram is so much more fractured and fragmented and spliced up that it's actually tough to get an idea of the overall shape of the distribution. It's like, if we're breaking it down by individual dollars, we can't actually see the overall picture because we're too focused on the details. If instead I change this bin size to $10, for instance, now it's actually tough to see the shape of the distribution because everything's too smushed together. So the hard part with histograms is always determining this bin size, and unfortunately there's really not that great of a way to do it. So what I would probably recommend that you do is take Tableau's default, which in our case was $4.43, and then just kind of move it to the value, the nearest value that makes sense. So for us, that's probably $5 increments. And so in $5 increments, notice we can get an overall sense of the shape of the distribution without smushing too many things together and without breaking too many things apart. This is completely a user-chosen parameter. Like, this is something you have to pick. And as we've seen, even necessarily, like, if we change this to $4, for instance, and you don't have to do this on yours, but just to show you, if we change this to 4, the shape of the distribution changes. Like, for instance, there's now this well, and like, oh, there's this thing over here. Like, if we go back and forth between these pictures, we do have slightly different results. And so the question is, how do you pick, and what's the best bin size? And there's really not much of an answer, unfortunately. You just kind of have to play around and say what's the most reasonable value that gets the story across. So sorry, can't be more definitive there. I mean, there are rules of thumb. For instance, there's a rule of thumb called the square root rule, where basically the number of bins that you should use is about the square root of the number of observations you have. And other people have other kind of rules of thumb, but they're just guideposts. They're not anything definitive. The one thing I also typically like, especially as a mathematician, but also just kind of to more quantitatively put things in context, is I often don't want this to be a count. I want it to be a percentage. And so if I go up to the rows here, which is the count itself, and I say quick table calculation, I can pick percentage of total. And now notice that the graph hasn't changed at all. The only thing that's changed is this axis here. But now this is saying that no matter how many books I have, this is about 35% of the total number of books. And this can be helpful, for instance, if you have varying amounts of data coming in each day and you want to show that these percentages are stable. It can also kind of shoot you in the foot. Like if someone says, okay, well, yeah, 35%, is that 500 books or 50 books? It just depends. Again, it's all context, but we have to have the tools in our toolkit in order to match the appropriate context. So we can change this axis, we can change the number of bins, but these are the two big things we have in our toolkit to kind of customize histograms to tell the story as best we can. In other videos, we'll talk about even more advanced options, but for now, I think this is a good start to making powerful histograms that tell good stories.